Hi everyone, I'm Gloria. Tonight we're going to talk about our final project. So there's lot of stuff to say, so I'm gonna be short and brief. I'm not gonna introduce our project here since it is so complicated. So we'll jump to the data visualization. There are approximately 20 indicators in our feature training data, and I have made a correlation matrix to see how the data is correlated. So the collinearity problem is gonna be huge if we include every single each of them. So I'm gonna choose three variables since they're from the temperature, humidity, and precipitation, based on the consideration of collinearity and the correlation between the total cases with all these each variables. So my choice are reanalysis of specific humidity index, the reanalysis of precipitation amount, and a reanalysis of dew point temperature. And then let's look at the historical records of the total cases of San Juan and Inquidios. So we can see a significant spike, significant two spikes in the San Juan's historical record, which are in the 1995 and 1998. And there are several spikes after 2005, and it's increasing. About the historical data of Iquitos, there's one significant spike after 2004, and after 2008 the data is very fluctuating and it's not stationary. So the data is not Y-North obviously, but what they gonna need for the transformation for maybe log, maybe box plus, or maybe differencing, it will depend on our further analysis. So there are missing values for the feature data, and my choice is to replacing them with the most recent data that is not any values. The reason I did not omit them because there are many of them, and the reason I chose the most recent not NA data is that I think those are like historical data of climate change. We don't need to do any like moving average for them. So the three models. So our purpose is to examine the relationship of the climate change on the disease, and also to predict the future disease based on the model's relations. So I chose the TSLM, which is the simplest, and regressions with the Riemann arrows, and the neural network. The all of the comments of those three models are that they can all include exogenous regressors. The GARCH cannot, maybe it can, but I don't know. And VAR is focusing on the relationship between two independent variables. So that is not what we gonna researching for. And the ETS, they cannot handle with exogenous regressors, and they perform bad when we have like periodical pattern that exceeding 24. So that's basically the reason why I chose those three models. So we can see from this summary that the TSLM does not perform well. The adjust R square is extremely low. That represent that about only 4% that the fitted value can only 4% of the data can be explained by our model, which is bad. this can also say that our model does not capture all the spikes, but we can see from the data that after 2005 the model seems fine because we have less spikes. And I think that's the reason that the TSLM forecasting result is not that bad. So for the ARIMA models, my original thought based on those GGTS display and all the NDF's command, my model choice was 510, but the AutoArima gave me another choice. The only flaws of this ARIMA model that we can see is that the prediction intervals is getting bigger. So this is not very pleasant. But things got better with the IQ subset. The prediction intervals fluctuating with our forecasting result. And this, what we are seeing now is for the neural network. I'm still very confused with neural network because the forecasting result performs differently on my two computers, and this is not the same as what I saw when I first run this code. I did not do any revision to the code, but I don't know why the results change. But I think neural network works best because it has the lowest RMSE. The TSLM has the highest RMSE, maybe around 50 for the SJ data, and the RMSE for the RQ data is, I believe it's about around 10. This is the lowest one. So I think before I submit my results, I think neural network performs the best because it has the lowest RMSE, and regressions with ARIMA errors is slightly not that perfect as neural network, but it's not bad. And let's see my submission scores. So 25, about 26 is for the TSLM model, and it has the highest score. It has the greatest score. And 30 is for the ARIMA model, and 32 is for the neural network. I don't know why it comes to this situation, but I believe there's something wrong with my my data analysis, because after I submit my work, I realized that there are some seasonal patterns. There are no obvious seasonal patterns in our historical data of total cases, but there do have seasonal patterns of climate indicators. That's the thing that I have ignored before. So I did some further changes. I differenced the data, or I also tried box clocks, but the result is also not pleasant, as we can see from the ARIMA summary that the coefficient of XREG is negative, which means it does not make sense. And so for the difference in data, or for the box clocks transformation, so I stuck there. I have no idea of how to perfecting my codes for my models, and I'm gonna leave these questions to you guys. Maybe you can help me to find out my solution. So I'm so happy to sharing my work with you, and please tell me there's anything that you find may help me to improve. Thank you.